Okay, folks, let's wrap up this final exam review. This is going to be part 3. The last part of the review, and I'm going to start with problem number 28. All right, 28. We got a quadratic equation because of the square, right? Which means we could use the quadratic formula. We could use it immediately because it's already equal to 0. But anytime you have something squared and just a number, it doesn't have an x term, then if you want to, you could just add the 36 to the other side. That'd give you 3x squared is equal to 36. Divide both sides by 3. And you have x squared is equal to, what, 12? Then you could use the square root property. Y'all know the square root property. We take the square root of both sides, take the square root of this side, square root of this side. Now, here's the deal. Anytime you throw that in, just willy-nilly, you can't do that. You have to put a plus or minus in front of one of those sides, okay? Because that's the deal about a square root. So x is equal to, this is going to be plus or minus the square root of 12. Now, you'd be done if that was a 5 under there. But 12 reduces. This is plus or minus the square root of 4 times 3, right? I can take the square root of 4. So my answers are plus or minus 2 square root of 3. Remember, I used up the square root symbol around the 4, but it stayed around the 3. Now, this is really two separate answers. Negative 2 square root of 3 is one of them, and positive 2 square root of 3 is the other one. Okay? This problem right here, very similar. You add the 25, divide by 144, and take the square root. So let's do that. You could also factor. You could factor both of these if you wanted to. You want to do this factoring instead. So this is a difference of squares. So is this. Well, that one wasn't because of the 3. You could. That one wasn't. You couldn't do that as a difference of squares. You can this one. Or you can add the 25 and divide by 144 and take the square root. Okay, just like we did above. But if you do it this way, 1 plus 1 minus, still equal to 0. The square root of 144 m squared is 12m in the first position. Square root of 25 is 5 in the second position. Now what? Set each factor separately equal to 0. Subtract the 5 over here. That's 12m is equal to negative 5. Divide both sides by 12. That gives you negative 5 twelfths. That's one of your answers. Add the 5 here, that's 12m equals 5. Divide both sides by 12, and you get m is equal to positive 5 twelfths. That's your second answer. I promised if you add the 25, divide by 144, take the square root, it'd give you plus or minus 5 twelfths, and you have it that way also. So let's move on to 23. All right, so we're supposed to evaluate. What does that mean? So this is this new notation you've been working on at the end of the semester. That is telling you, that is not multiplication. That is telling you, what is going on? That is telling you, hold on, I gotta get rid of that little box, whatever it was. It's telling you to plug 1 everywhere there's an x. So f of 1 is equal to 2 times 1 squared minus 3 times 1 plus 1. Everywhere there's an x. So I took out this x and replaced it with 1. I took out this x and replaced it with 1. And wrote down the whole function as is. Now I just got to simplify. I got to do the math. So you do exponents first. 1 squared is 1, so that's 2 times 1 minus 3 times 1 plus 1. Then you multiply. 2 times 1 is 2. Multiply here. 3 times 1 is 3 plus 1. Then 2 minus 3 is negative 1 plus 1 is 0. So the answer to that is 0. Okay? The domain of this ordered pair, remember these are x, y, x, y, x, y, all the way across. Domain is your x values. Now, it's written as a set. So, negative 2 is part of the domain. 0 is part of the domain. 4 is part of the domain. 6 is part of the domain. And 5. What if some of those repeats? You don't write them repeated. So, if, say, 0 showed up both more than 1 point, you only write it 1 time. Okay? Next problem. Oh, there it is again. There's the domain. Now we're talking about the range. Well, the range is your y values. So your range, again, is a set of ordered pairs. 2, 1. See, there's a 1 again. I'm not going to write it again. 7, 3. So if there's repeats, don't repeat it. Okay? Does the set of ordered pairs define a function? For a function, for each x value, there's only one y. Only one y value. So for x equals -2, the y value associated that was 2. Do you see -2 for an x value again? No. So for -2, there's only one y value. For 0, the y value is 1. Check to see if there's another 0. So for 0, there's only one y. For 4, there's only one y, it's 1. For 6, there's only one y, it's 7. For 5, there's only one y, it's 3. And most people look to see if the x's repeat. And if they don't, then likely the answer is yes. But there is a situation that if they repeat and you have the same y value there, then it still could be a function. So be really careful. Somebody could be sneaky about that. All right, we're almost done. We need to rationalize. How do you do that? Well, you're not supposed to leave square roots in the denominator. If all you have is just a single monomial, one term, then to rationalize, you just multiply the numerator and the denominator by whatever radical's in the denominator. So the 6 stays in front. Square root of 5 times square root of 3 is the square root of 15. Square root of 3 times square root of 3 is square root of 9, which is 3. Now this reduces. This 3 goes into 6 2 times, so the final answer there is 2 square root of 15. It's a little more complicated when you have plus or minus in the denominator, but what you do is you multiply by the opposite. Okay, 3 plus the square root of 7 on top and bottom. So whatever operation is here, you change it. It's called the conjugate of the denominator. Now I have to distribute here. So 5 times 3 is 15. 5 times the square root of 7 is just that, 5 square root of 7. In the denominator, I got a FOIL. 3 times 3 is 9. 3 times the square root of 7 is 3 square root of 7. Negative 3 times the square root of 7. Notice I changed the order there when you multiplied. And then negative 7 times positive 7 is negative square root of 49. Now I got some simplifying to do, right? These cancel. You know what? They always will. When you multiply by a conjugate, those things will cancel 100% of the time. That's the point. And then square root of 49 is 7, so that's 9 minus 7, which is going to give me 15 plus 5, square root of 7, and we know 9 minus 7 is 2. So that is completely simplified. Problem 36, we're asked to evaluate. Notice this is a cube root of 27. So you need to have an idea of what perfect cubes are. Like 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. You know, you can make a big list, but look, 27 landed right there on our list. So the cube root of 27, you could even think about it this way, the cube root of 3 to the third, right? And these cancel each other out and just give you 3. Or you just know that the cube root of 27 is 3. The cube root of negative 8, you know, well, here's 8 on our list. It is a perfect cube. What about the negative? You can take the cubed root of negative numbers. So one way to think about it is negative 8 is negative 2 to the third. And the cubed root and the cube cancel each other out, and that is just negative 2. All right, here's a fun one. Okay, so we've got x to the 1/3, x to the 2/3, x to the negative 1/5. We're supposed to simplify this. Now, you can't do this. Don't let the fractions intimidate you. You can't do this unless you know those properties of exponents. So, you know, when you multiply bases, you add exponents. When you divide bases, you subtract exponents. When you have a power raised to another power, you multiply exponents. Well, up here, we are multiplying bases, so I need to take these two guys and add those exponents together. So, let's just stop and do that now. Okay? So, that's x to the 1/3 plus 2/3. And recopy in the denominator x to the negative 1/5. Well, hey, I already have a common denominator. That's helpful. That's x to the 1 plus 2 is 3/3, right? Just adding fractions. You keep that denominator, common denominator, you add the numerator, and x to the negative 1/5 here. Now, we could simplify 3/3 as 1, x to the first over x to the negative 1/5. But now here's where it gets interesting. You're dividing, that means subtract. So just write that down. I'm subtracting x. And I always do bigger minus smaller. Well, the bigger one's on top because that's a negative. So 1 minus a negative 1/5. Right? It's just not 1 minus 1/5. It's 1 minus, because the rule is subtract, and that happens to be a negative 1/5. So this is the same as x. Remember, keep change. Okay, so this is going to be 1 plus 1/5. But now I can't add these together without finding a common denominator. So 1, I'm going to rewrite that as 5/5. Right? That gives me a common denominator. And then 5/5 plus 1/5 is x to the 6/5. And there you go. I think we got one more problem. We do. Write the following rational exponent expression in radical form. You know, radical form, let me get my pen working. Radical form is this type of thing. That's a radical. Rational is a fraction. So whenever you hear rational, that means fraction. When you hear radical, that means these square roots, cube roots, that kind of thing. All right, so we know the rule, at least I hope you do, that the denominator is the radical and the numerator is the exponent. So I have my y, my radical is the 7th root, and then my my exponent, which is the numerator and the fraction, goes up there. And that's it. Now, if the numerator is bigger than the denominator, we would need to simplify, but most of the problems you have to deal with are like this. Okay, I hope this helps. Now, there are word problems that also are associated with this final exam. It's a separate review, so please, please, please make sure you do those word problems. If you're having any issues, any questions about the review, whether it's the typed one or a question or this video review, please let me know. Good luck. I hope it goes great.